Welcome back, everybody. This is Professor Bruce Hartpence from Rochester Institute of Technology with another networking video. Today we are going over Chapter 5 in the Packet Guide to Routing and Switching, and that is the Routing Information Protocol, or RIP. And I'm going to break this into a couple of parts, and this is part 1 with the basics of this ubiquitous routing protocol. So without further ado, off we go with RIP. What have we talked about so far? If you've been following along in this video series, we started off with general routing and switching. So we've talked about switches and what they are, how they make decisions, source address tables, also known as MAC address tables. We extended that into VLANs and trunks, and that's how we divide up layer 2 networks and we route between them. And the industry standard trunking protocol is, of course, 802.1q. Cisco has its proprietary ISL. And now we're going to talk a little bit more about routers. Now, as I said, Chapter 1 in this particular series is on routing and switching strategies. So I talked a lot about the basics of routing and some of the decisions that have to be made. And with this part of the series, we're going to talk a little bit more about specific types of routes and dynamic routing in particular. Just as a little bit of review, we've got on a router 3 basic kinds of routes. We have directly connected routes, and what that means is the minute you give a router an IP address, or if it's got several interfaces, lots of IP addresses, and you bring those interfaces up, the routing table begins to be populated with what are called connected or directly connected routes. So these are automatic. And then if you've got a small topology or one that doesn't have a whole lot of changes in it, a lot of times we will insert static routes. These are manually configured. We tell the router how it's going to forward traffic. Default routes are an example of a static route. Dynamic routing are for those networks that are large, that may have changes, but dynamic routing also adds the ability to detect and recover from loops or losses in links or downed network devices. RIP is an example of a dynamic routing protocol. Now, I suppose it's difficult to talk about routes and routing and routers if we don't discuss a little bit about how routers make decisions, or how they add routes. There are 3 values that we associate with routes. The first one is the prefix length, and this is actually the big one, the one that we consider to be most important. The prefix length is sort of a measure of how close you can get to a destination. So if I have a network with a /24 subnet mask, that's pretty close. It's much closer or much more specific than a /16 or 15 network mask. So we like having prefix lengths that get us very close to the destination. The example that I always use is a city. If you were trying to mail something to someone, you'd want more information than just the city or even the town or the street. You want the house number, and that's what we get when we have a long prefix length. Admin distance is actually a value that we use to compare different kinds of routes. Static routes have a value of 1. Directly connected routes are the highest prized type of route. You can't beat a directly connected route because it's right there. Static routes are manually configured, so we figure that you want to use those, so they have a low administrative distance as well. And then we start comparing dynamic routing protocols, and each one of these has an administrative distance. And there's the examples for OSPF and RIP. The last value that we have is the metric. And the metric is what we use to compare routes learned from the same routing protocol. So if you learned something from one OSPF router and learned the same destination from another OSPF router, you would compare the metric to see which one you liked best. Now let's take the example of a directly connected topology. Here we've got a router in between 2 networks. The minute the router interfaces are brought up and the router would be given IP addresses, we can see that the routing table is populated with the directly connected routes. And The circle there indicates that these are connected. There's the little letter C there. We can also see which interface is connected to which network. And this is a basic topology, but this is part of every single router that's connected to a network. Well, if we start to take a look at static routes, the top part of our command window here, I've given you the commands that you would issue to provide a static route. And in this case, we're just doing one of the router examples here. And we can see the two commands that we've used to get to the networks that are not directly connected. So down below, we see the router's routing table. We can see that we've got two networks directly connected. See if you can figure out which router we're talking about here. And then I've added two static routes that allow us to get to the other networks that are not directly connected. Now, here's a pro tip, gang. Make sure that you use as the forwarding router interfaces the last field in this command. You want to make sure that you use the IP address of your neighbor. Do not use an interface there alone. If you want to add an interface at the end to be very specific, you can, but you have to have an IP address of a forwarding router. That's really important if you're just getting started off in routing. And we can see that when we add these commands, that the routing table updates, and we can see the little letter S next to the static routes that we've added in the routing table. Well, we're off to dynamic routing now. And in dynamic routes, what we're really talking about are routing protocols. And our first routing protocol that we're going to talk about is, of course, the Routing Information Protocol, or RIP. Been around for a long, long time. It is an example of what we call an interior routing protocol. That means you build a network for a company or an organization, and the thing that you use internally for your own networks is going to be RIP. So we don't use it to talk to other autonomous systems. So the idea with most routing protocols is that each router shares what it knows with its directly connected neighbors. And they do this by passing messages back and forth. Once a router receives a message from a neighboring router, it takes a look at the message, processes what's in the message, and determines whether or not the information is better than what it already has. So we're making a couple decisions when we get this. One, do I want to add this to my routing table? And once it's added to my routing table, is it the best possible route for forwarding to a destination? Now, it's possible that you can have IP networks reached with two different entries in a routing table, and we'll talk more about that as we get through some more complex examples. All right, let's get back to Chapter 5 and RIP. Here we have the same topology that I showed you earlier for static routes, but this time we're going to just do some steps, and then we're going to move into routing protocols and not static routes. If we took this topology and we connected it all together as shown here and assigned the IP addresses and just brought the interfaces up, what you would see on the three routers are routing tables that would look like those below. So each router would have a pair of directly connected routes. And that's it. Beyond that, we actually have to do something. So on each router, what we're going to do is turn on RIP. And in this case, I think we're talking about RIP version 2 is the example that we have later on. And I'll give you a RIP config as we go through some more examples. Now, once we turn on RIP, there is an exchange of request and response messages in RIP. And you can see here that I've targeted just one particular segment of the network. So here we've got two routers passing routing information back and forth. Now this happens all over the topology. Everywhere you turn on RIP, these messages start to fly, but I've just provided examples from one segment. Now let's assume that all of the routers are doing RIP and passing these sorts of messages back and forth. What ends up happening is that we wind up with routing being populated with the information that we didn't know. So here we have each router with its directly connected routes now, but take a look at the routing tables. All of them have now updated their routing tables to include information for networks that they didn't know about before. You noticed in this topology probably that there are 4 networks. So each router eventually will have entries for the 4 networks. That is, unless you're doing default routing. So here each one of the routers has all 4 networks in the routing table, but each one of them has a pair of RIP learned routes. When a router receives an update from its neighbor, it takes a look at that, and if it populates the routing table with information learned from that router, then it's going to add the routing table entry for not only the destination network, but also where it learned it. This is an example of a RIP packet that was sent out from one of the routers. Now, if we start at the top and we take a look at the destination address at the IP level, see that it's a multicast, and we can also see that there's some multicasting going on at layer 2. So if you are confused by that multicast, I would suggest you look at some of my earlier videos that describe when and where these sorts of addresses are used. But what I did was open up the RIP packet and sort of went through some fields here. The important part here is I also expanded part of the packet for one particular network, the 2net. So we've got that it's an IP network, that the destination is actually the 2net. We've got the mask for this. This is an indication that we've got RIP version 2 running here. And I've also provided an arrow there for the metric. This gives us an idea of how far away this particular network is in a RIP topology. So RIP uses as its metric hop count. That is how far away I am by the number of routers that I sort of have to cross. Now this came from router number 1. And so the 2 network, this was actually passed to the 1 network from interface 1.254. And so it makes sense that the 2net is actually 1 hop away. We can also see that there are entries for the 3 and the 4 nets because those were also learned from the right interface, and so we're passing this information out the left interface. Let's take a little closer look at a routing table. If we take a look at this line that I've got circled here, we can see that we've learned about a particular route or a particular network destination, and then we've got those numbers in the brackets. Those numbers in the brackets are the admin distance and the hop count. So here that 120, that's the administrative distance for RIP, and the number after the slash is the metric or how far away this particular network is. And then there's also an indication of where I learned this particular network or what interface I used to learn this particular network. Well, I think that's enough for this episode. I'll be back next week with the Routing Information Protocol Part 2, and we'll go through some more examples, and then we'll talk about some of the concepts that routing protocols use to optimize the transmissions or optimize the routing of packets, things like poisoning and split horizon. Remember that this was the Packet Guide to Routing and Switching Chapter 5, and you can go out to brucehartpence.com, catch up on community configs and posting capture files out there and lots of other videos. And of course, there's the other stuff going on here with the channel. Thanks again for watching, thanks again for listening, and may your packets always reach their destinations.